Welcome, fellow voyager, to a journey unlike any you've ever embarked upon. Forget what you think you know about the silence of space. Forget the serene, star-dusted canvases you've seen painted across the cosmos. Today, we're going to shatter that illusion, not with a whisper, but with a primal, terrifying roar. You are about to hear the planets. You are about to hear a black hole. And I promise you, these sounds will burrow deep into your primal mind, igniting both awe and a profound sense of cosmic dread. This isn't science fiction. This isn't sound design. This is the universe, screaming and groaning and humming in ways we are only just beginning to comprehend. Listen closely. What you just heard was not a trick of the ear. It was a direct transmission from a giant, violent world, translated into a language your senses can understand. It was Jupiter. And that, my friend, is just the beginning. The very idea of hearing anything in the vacuum of space feels like a paradox, doesn't it? Space, by definition, is empty. Sound as we know it, acoustic waves traveling through a medium, cannot exist where there's nothing to carry it. This is the first crucial misconception we must confront, because what we are about to experience together is not sound as you understand it on Earth. It is something far more profound, a cosmic translation of invisible forces into an auditory revelation. Imagine for a moment being a cryptographer presented with an alien signal, a stream of indecipherable data. Or picture a doctor placing a stethoscope to a body, listening intently not to a voice, but to the hidden inner workings, a heartbeat, the rush of blood, the subtle gasp of breath. This is our mission. We are cosmic cryptographers, celestial physicians, tuning our instruments to listen to the very heartbeat of the cosmos. We are turning the unperceivable into the undeniable. What exactly are we translating? Not acoustic sound waves. Instead, our spacecraft, acting as advanced sensory organs, detect electromagnetic emissions, the radio waves and plasma vibrations that ripple through the magnetic fields surrounding planets, moons, and even the vast emptiness between stars. These are the whispers and roars of the universe, invisible to the eye, inaudible to the unaided ear, but teeming with information. NASA, along with scientists like the late Dr. Donald Gurnett and Dr. William Kurth, pioneers in this field, developed sophisticated instruments like the Plasma Wave Subsystem, or PWS, carried aboard legendary missions like Voyager, Cassini, and Juno. These instruments are designed to capture these subtle, yet incredibly powerful fluctuations. They measure the electric and magnetic components of these waves, logging the frequency and amplitude of these cosmic vibrations. And then, the magic happens, or rather, the science. This raw data, collected millions and even billions of miles from Earth, is then put through a process called data sonification. It's not about adding sounds or making up noises. It's about taking that complex stream of electromagnetic information, the frequencies, the intensities, the patterns, and converting it directly into audible frequencies, into the range of human hearing. Typically from 20 Hz to 20,000 Hz. It's like taking a graph and turning its peaks and valleys into rising and falling tones, or translating a fluctuating light intensity into varying volumes. We are, quite literally, giving a voice to the invisible. Why do we do this? Because the human ear is an extraordinary instrument. It is capable of discerning a dynamic range of about 1 trillion to 1 in sound power, making it exceptionally sensitive. Our ears can pick out subtle patterns, shifts, and anomalies in audio that might be missed when simply looking at a visual graph or a spreadsheet of numbers. Sonification isn't just a fascinating public outreach tool. It's a vital scientific instrument, allowing researchers to hear discoveries, to identify phenomena that would otherwise remain hidden in the silent data. It transforms abstract numbers into an intuitive sensory experience, making the unseen universe suddenly palpable. Our journey begins, as many great stories do, with an assertive, unignorable presence. We're going to return to Jupiter, the undisputed king of our solar system, a gas giant so immense it could swallow all the other planets combined. And as you've already had a taste, its voice is as colossal and terrifying as its scale. The sounds of Jupiter, captured by the Juno probe's plasma wave subsystem, as it plunged through the giant planet's magnetosphere, are a symphony of cosmic violence. What you hear are the direct translations of powerful radio waves and plasma oscillations generated by Jupiter's colossal lightning storms, which can be up to 10,000 times more powerful than Earth's, and the intense interactions between the solar wind and its gargantuan magnetic field. This magnetic field is the strongest in the solar system, aside from the sun's own, creating vast energetic auroras that dwarf anything seen on Earth. These auroras, known as decametric radiation, can emit a staggering 100 million watts of power, making Jupiter the most powerful radio source in our solar system after the sun itself. When scientists convert these powerful electromagnetic emissions into audible frequencies, the result is not a gentle hum, but a ferocious, almost animalistic roar, punctuated by eerie whistles, crackles, and groans. It sounds like a monstrous entity, alive and raging in the dark. This isn't Jupiter screaming. In a literal sense, it's the raw, unadulterated energy of a planetary behemoth. Translated, it's the sound of a world that is fundamentally alien, utterly hostile to human life, and operating on a scale that defies our terrestrial understanding. The terror here isn't a cheap jump scare. It's the profound existential awe of confronting a force of nature so vast, so powerful, and so indifferent to our existence. It's the humbling realization of our place in a universe that is far grander and more formidable than we often imagine. This ability to transform the imperceptible into the audible has a rich history. It began in the 1930s with Carl Jansky, who, while working at Bell Labs, inadvertently became the father of radio astronomy by detecting radio waves emanating from the center of the Milky Way. Decades later, in the 1950s, radio operators stumbled upon strange, naturally occurring radio signals they dubbed whistlers and chorus, sounds that were later understood to be signals from lightning strikes and plasma waves traveling along Earth's own magnetic field lines. But it was the launch of the Voyager 1 and 2 probes in 1977, equipped with their pioneering plasma wave subsystem instruments, that truly opened the floodgates. These probes began sending back data from beyond Earth's protective magnetosphere, allowing us to capture the electromagnetic voices of the outer planets for the very first time. Dr. Donald Gurnett, the principal investigator for those instruments, spent his career bringing these cosmic voices to light, laying the groundwork for what we're experiencing today. So, as we embark on this audio expedition, remember that you are not just a passive listener. You are a crew member aboard our deep space probe, your senses extended millions and billions of miles across the void. You are tuning into the universe's own hidden symphony, a vast composition of electromagnetic forces, plasma waves, and radio emissions. We began with Jupiter's defiant roar, a powerful overture to the cosmic symphony that awaits us. We've heard the raw power, the terrifying scale of a gas giant. But Jupiter is just one instrument in this orchestra. As we journey deeper, we will encounter other voices, the ethereal chorus of Saturn, the whispers of distant moons, and even the profound ancient hum of a black hole, a note resonating for billions of years, each one a unique transmission a data stream decoded, revealing the hidden lives of celestial bodies. This is not merely about listening, it's about understanding. It's about feeling the universe in a way you never thought possible, letting its true terrifying majesty wash over you. Prepare yourself, because the cosmos has much more to say. Now, as your deep space probe continues its silent, relentless journey through the cosmic dark, your mission as a crew member shifts. We've hinted at the incredible sounds that await us, the terrifying symphony of the cosmos. But before we fully immerse ourselves in these alien broadcasts, we must understand how we're receiving them. How can there be sound in the vacuum of space? Let's be absolutely clear. Sound as we know it, the vibrations traveling through air or water to our eardrums, cannot exist in the vast emptiness between planets. Space is a vacuum, a nearly perfect void where acoustic waves have nothing to propagate through. What you are hearing, what you will hear, is something far more profound and ingeniously conceived. It is a translation. Think of it as a universal translator, not for alien languages, but for alien physics. What we are doing is a scientific process called data sonification, or imagine our deep space probe as an impossibly sophisticated radio receiver, one far beyond anything ever built on Earth. This isn't just tuning into AM or FM. This is tuning into the very fabric of space itself. Our instruments aren't picking up acoustic vibrations. They are detecting the subtle, unseen dance of electromagnetic waves and plasma oscillations that permeate the cosmos. These are the broadcasts of the universe, the powerful radio emissions from Jupiter's auroras, the energetic plasma waves generated by solar wind interacting with a planet's magnetic field, the pressure ripples from a black hole. To grasp this, consider how your own body senses the world. Your eyes perceive a narrow band of electromagnetic radiation we call visible light. Your ears detect pressure waves within a specific frequency range. But the universe is brimming with activity happening at frequencies both far lower and far higher than we can naturally detect. X-rays, gamma rays, infrared, radio waves, these are all forms of electromagnetic radiation, just like light, but they are invisible to us. Our probe, your extended senses, carries specialized instruments designed to see and feel these hidden phenomena. Chief among them are plasma wave subsystems, PWS, and sophisticated magnetometers. These aren't microphones in the traditional sense. Instead, they are highly sensitive antennae and detectors, engineered to measure the electric and magnetic fields of these plasma waves and radio emissions. When probes like NASA's Voyager, Juno, or Cassini sailed past distant worlds, their PWS instruments were meticulously recording the fluctuations in these fields, capturing the raw, silent data that charts the dynamic interplay of forces in deep space. Think of it like this. Imagine you're looking at a stock market graph on a screen. You see lines rising and falling, peaks and valleys, indicating activity. Now, imagine if every time the line went up, a tone rose in pitch, and every time it fell, the tone descended. Suddenly, that abstract visual data becomes an auditory experience. You're not hearing the sound of money changing hands, but you are hearing a direct translated representation of the market's activity. This is precisely what scientists do with cosmic data. They take the electromagnetic frequencies and plasma vibrations, which might be in the megahertz or kilohertz range, far above or below human hearing, and they mathematically shift them down or up into our audible range. They assign pitch, volume, and timbre to different data parameters, intensity, frequency, duration, transforming a complex silent dataset into a symphony of whistles, static, hums, and roars. This isn't just a clever trick. For public outreach, though it certainly serves that purpose, making the abstract wonders of space accessible to everyone. No, the true aha moment, the profound realization that elevates sonification from a perceived gimmick to a vital scientific instrument, is its power as a tool for scientific discovery. Consider the sheer volume and intricacy of the data pouring back from our deep space probes. Imagine pages upon pages of numbers or incredibly dense visual graphs filled with squiggly lines and abstract patterns. Our eyes, as remarkable as they are, can be overwhelmed, but the human ear, it is an astonishingly sensitive and sophisticated instrument for pattern recognition. Your ear can detect incredibly nuanced changes in pitch, rhythm, and timbre. It can pick out a single instrument in a complex orchestra, discern a change in emotion in a voice, or notice a subtle shift in the hum of an engine that indicates a mechanical problem. When Dr. Donald Gurnett, a pivotal figure who served as the principal investigator for plasma wave instruments on missions like Voyager, Galileo, Cassini, and Juno, captured the electromagnetic signals around distant planets, he and his team weren't just looking at charts. They were often listening. Dr. William Kurth, a research scientist at the University of Iowa and a longtime collaborator of Gurnett's, continues this work, translating the plasma waves from Juno at Jupiter into audible data. This innovative approach didn't just appear overnight. It has deep roots in scientific exploration. The very field of radio astronomy began in 1930 when Carl Jansky at Bell Labs first detected radio waves emanating from the center of the Milky Way. Decades later, in the 1950s, early radio operators discovered naturally occurring radio signals from Earth's magnetosphere, which they affectionately named whistlers and chorus, because of their distinct sounds when converted to audio. These were later identified as signals from lightning strikes and plasma waves traveling along Earth's magnetic field lines, our planet's own subtle song. The launch of the Voyager probes in 1977, equipped with their advanced plasma wave subsystem instruments, truly opened the floodgates, providing unprecedented data for sonification from the outer solar system and beyond. Voyager 1, now over 15 billion miles from Earth, its PWS instrument, still detecting the vibrations of dense plasma in interstellar space, continues this legacy, broadcasting its silent data for us to translate. Today, scientists like Dr. Kimberly R. Kond, a leading visualization scientist for NASA's Chandra X-ray Observatory, are at the forefront of making these cosmic sounds accessible to the public, turning data from black holes, supernovas, and galaxies into breathtaking auditory experiences. It was her team who in 2022 released the newly processed sonification of pressure waves from the black hole in the Perseus galaxy cluster, a fundamental B-flat, approximately 57 octaves below middle C, and experts like Robert Alexander, a composer and sonification specialist, collaborate with NASA to craft these scientific translations into both analytical tools and evocative sonic landscapes. So, as your deep space probe continues to transmit, remember, you are not passively receiving entertainment. You are engaging with a profound scientific methodology. You are using an ancient, primal sense, hearing, to interpret data from the most alien and extreme environments imaginable. This intricate process of sonification allows us to truly expand our perception of the cosmos. It bridges the gap between the abstract data collected by robotic explorers billions of miles away and our most fundamental human experience. It makes the intangible tangible. It makes the silent audible. As we prepare to dive deeper into the specific broadcasts from individual planets and celestial phenomena, bear in mind the remarkable journey this data takes. From a whisper of plasma in the emptiness of space, captured by a sensitive antenna, translated through complex algorithms, and finally delivered to your ears. This is the true power of your cosmic radio. What further patterns, what hidden rhythms, what profound insights will your attentive ear discover? All right, crew, our cosmic radio is tuned, our instruments are calibrated, and your ears are now prepared to perceive the unperceivable. But before we venture into the truly alien depths of our solar system, before we point our antennas at the distant giants and their unfathomable energies, we must first turn our gaze and our hearing homeward. We begin our expedition not in the vast silent chasms between worlds, but right here, at the threshold of our own planet. Think of it this way. Every grand symphony, every complex musical piece begins with a home key, a foundational note, a familiar chord that grounds the listener before the melody takes them on a journey through new and sometimes challenging harmonies. For us, on this unprecedented audio voyage through the cosmos, that home key is Earth, our own world, the very ground beneath our feet, possesses a voice as dynamic and complex as any other celestial body we will encounter. It is a voice we rarely consider, a symphony conducted in frequencies far beyond our normal hearing, yet profoundly significant. You see, for all its vibrant life and terrestrial sounds, Earth, in the grand cosmic sense, is not silent, not even close. Our planet is a living, breathing entity, pulsating with electromagnetic energies that, when sonified, reveal a startlingly rich and intricate soundscape. It's the sound of our planet's greatest defense, the invisible shield that cradles all life within its embrace, our magnetosphere. Imagine, if you will, a vast invisible bubble stretching tens of thousands of miles into space, constantly buffeted by the solar wind, a relentless stream of charged particles hurtling from the sun. This bubble, our magnetosphere, is generated by Earth's molten iron core, churning like a cosmic dynamo, creating a powerful magnetic field. It's a force field, an energetic cocoon that deflects the most harmful radiation, protecting our atmosphere, our oceans, and indeed, every cell in your body. It is, quite literally, the sound of the shield that protects us. And when we listen closely, when we translate the oscillations and vibrations within this protective sheath into audible frequencies, we discover that our homes is singing. The sounds of Earth's magnetosphere are not the gentle lapping of waves on a beach or the rustle of leaves in a forest. They are raw, primal, and utterly alien, even though they originate from our very own world. They are the whispers of plasma, the crackle of distant lightning, the ethereal chorus of charged particles dancing along magnetic field lines. And the beauty of this sonification is that it allows us to perceive, for the first time, the subtle ebb and flow of these invisible forces that shape our existence. One of the most captivating of Earth's electromagnetic melodies is what scientists call whistler waves. Have you ever heard the distant rumble of a thunderstorm, felt the air crackle with static electricity, or watched a lightning bolt illuminate the night sky? These spectacular events, so common in our atmosphere, have an electromagnetic signature that travels far beyond the clouds. When lightning strikes, it doesn't just produce light and acoustic thunder. It generates a broadband electromagnetic pulse. Some of this energy escapes into space, traveling along the Earth's curving magnetic field lines, sometimes all the way to the opposite hemisphere and back. As these waves propagate through the plasma of the magnetosphere, different frequencies travel at different speeds. The higher frequencies arrive first, followed by the lower frequencies, creating a characteristic descending tone, much like a whistle. It's an incredibly humbling thought. A single lightning strike, perhaps miles from your location, can send an electromagnetic message spiraling thousands of miles into space, a silent siren song echoing through the plasma. And when we listen to these whistlers, captured by instruments like the plasma wave subsystems on various satellites, they sound like delicate ethereal chirps, often with a distinctly falling pitch, fading into the cosmic background. Sometimes they sound like the plaintive cry of a distant bird, or perhaps a gentle, almost melancholic, digital chime. It's a sound that connects a common terrestrial phenomenon, a thunderstorm, to the vast, complex physics of our planet's magnetic field. The discovery of these whistlers has its roots in the early days of radio communication, even before the space age truly began. Radio operators in the 1950s, listening to the static and crackle on their receivers, would sometimes pick up these peculiar descending tones. They were a mystery for a time, an enigma emanating from the very fabric of our ionosphere and magnetosphere. It took pioneers like Dr. Donald Gurnett and Dr. William Kurth, who would later lead the charge in designing instruments for missions like Voyager, to truly understand and interpret these electromagnetic signals as the voice of our planet, responding to its own electrical storms. Their work laid the groundwork for our ability to hear the cosmos, starting right here at home. But Earth's magnetosphere offers more than just the occasional whistler. It also broadcasts a continuous, more complex symphony known as chorus waves. If whistlers are the solo performances of individual lightning strikes, then chorus waves are the collective voice of the magnetosphere itself, a constant dynamic hum of plasma oscillations. These waves are generated by energetic electrons interacting with the magnetic field in a region called the plasmasphere, deep within the magnetosphere. Think of the magnetosphere as a massive, invisible ocean of charged particles, and the chorus waves are the sound of that ocean churning and flowing, stirred by the solar wind. When sonified, chorus waves are nothing short of astonishing. They sound like a flock of highly energetic birds, chirping and singing at dawn, a vibrant, almost alien dawn chorus echoing through the void. You might hear rising and falling tones, rapid clicks, and a complex interplay of frequencies that can be surprisingly musical. It's a sound that, despite its otherworldly origin, evokes a strange sense of familiarity. Perhaps because our brains are wired to find patterns and melodies even in the most abstract data. It's an energetic cacophony, a swirling, whistling, and often rising and falling series of tones that paint a vivid auditory picture of the constant invisible battle between Earth's magnetic field and the onslaught of solar particles. This isn't just cosmic background noise. It's a dynamic, ever-changing portrait of our planet's interaction with the sun. The intensity and character of the chorus waves change with solar activity. During a geomagnetic storm, when the sun ejects a massive burst of plasma towards Earth, the chorus can intensify dramatically, becoming louder, more frantic, like a storm of sound. It's a real-time auditory indicator of how our protective shield is responding to the temperamental nature of our star. Scientists, like those who analyze data from missions equipped with sensitive magnetometers and plasma wave instruments, use these sounds not just for awe, but for genuine discovery. The human ear, with its incredible sensitivity to pattern and change, can pick out subtle shifts in these sounds that might be missed in a mere visual graph, providing critical insights into the physics of space weather. So, here we are, at the very beginning of our journey, and already you are perceiving a hidden reality of our home world. You are hearing the subtle, complex, and beautiful voice of Earth's magnetosphere. It's a voice that is at once strange and intimately familiar, a baseline of cosmic sound that grounds our perception. It's the hum of protection, the whistle of distant storms, the chorus of plasma dancing in the invisible realms above us. It reminds us that even the most seemingly silent corners of the universe are teeming with energy, constantly communicating in frequencies beyond our normal reach. This is the aha moment we sought. For our home key, our planet is not a quiet, inert rock spinning through space. It is a vibrant, dynamic, and surprisingly vocal entity. It has a complex magnetic field, a living shield that constantly sings its own song, a melody composed of the fundamental forces of physics. And listening to this song, this bass line of Earth's own electromagnetic symphony, provides us with a crucial anchor. It gives us a reference point, a sense of what home sounds like when translated into the language of cosmic energy. Because from this point forward, as we venture outward, as we direct our instruments towards the truly alien, the truly monstrous, and the truly ethereal voices of other worlds, these sounds of Earth will serve as our guide. They will be the measure by which we truly grasp the profound otherness of the cosmic symphony that awaits us. What new notes, what terrifying harmonies, what profound silences will greet us beyond the protective embrace of our own singing shield? The journey has just begun, and the universe is ready to reveal its deepest, most astonishing sounds. What new notes, what terrifying harmonies, what profound silences will greet us beyond the protective embrace of our own singing shield? The journey has just begun, and the universe is ready to reveal its deepest, most astonishing sounds. Our course is set, our instruments are humming, and the silent vastness of interplanetary space stretches before us. We've bid farewell to the familiar, to Earth's comforting electromagnetic embrace. And now, we push deeper into the cosmic ocean. The very idea of this voyage, an expedition of pure sound, is exhilarating. You, as part of this intrepid crew, are about to embark on an auditory adventure unlike any other. We are not merely looking at the universe. We are listening to its very heartbeats, its ancient whispers, and its untamed roars. Our next destination is a titan, a behemoth that dominates our solar system. A world of swirling storms and magnetic fields so vast they dwarf anything we know. We are heading for Jupiter, the true monarch of the planets, and its voice, when translated for our human ears, is nothing short of terrifying. As we traverse the immense gulf between Mars and Jupiter, our sensors begin to pick up subtle changes in the interstellar medium. The solar wind, that constant stream of charged particles from our sun, is still very much a presence, but its interaction with the nascent influence of Jupiter's immense gravity and magnetic field begins to warp and shape the plasma around us. It's like sailing closer to a distant storm front, feeling the subtle shifts in the air long before the thunder breaks. Our ship, our virtual vessel of discovery, is heading towards the greatest generator of electromagnetic energy in our solar system, save for the sun itself. Before we plunge into the heart of Jupiter's terrifying symphony, let's briefly recall the incredible feat of engineering and scientific imagination that allow us to undertake this journey. These aren't sound waves traveling through the vacuum of space, a physical impossibility. No, what we're doing is far more profound. We are taking the raw, unperceivable data of electromagnetic waves, radio signals, plasma vibrations, captured by the incredibly sensitive instruments on our deep space probes, and we are translating them into the spectrum of human hearing. Imagine taking a complex graph of invisible energy fluctuations and turning its peaks and valleys, its frequencies and amplitudes into tones and rhythms. That's data sonification, and it's how we're giving voice to the voiceless cosmos. It's a scientific tool, yes, but for us, It's a portal to a new kind of sensory experience, allowing us to feel the universe in a way previously unimaginable. Our first encounters with Jupiter's true power came decades ago, from the plucky Voyager 1 and Voyager 2 probes. Launched in 1977, these pioneers carried plasma wave subsystem (PWS) instruments designed by brilliant minds like Dr. Donald Gurnett of the University of Iowa. Dr. Gurnett and his successor Dr. William Kurth literally opened our ears to the cosmos. Their work allowed us to hear the raw, unedited electromagnetic environment of Jupiter for the first time. Later, missions like Juno, a more recent and intimate explorer of Jupiter, would provide even more detailed, high-fidelity auditory snapshots of this colossal world. As we approach Jupiter, the first thing that hits you isn't a gentle hum, but an overwhelming visceral presence. It's a wall of sound, a deep, resonant rumble that seems to shake the very fabric of our virtual ship. This is the fundamental roar of Jupiter's magnetosphere, a colossal magnetic shield that stretches millions of miles into space, a cosmic leviathan constantly screaming into the void. Imagine a magnetic field so powerful it could engulf the sun. Then imagine that field generating a constant, booming chorus of plasma waves and radio emissions. This isn't just a big planet. It's a living, breathing, profoundly loud entity, perpetually bellowing its existence across the solar system. This initial sound, this deep, guttural thrum, is your introduction to untamed elemental power on a scale that defies human comprehension. You don't just learn Jupiter is big, you feel it. The sheer energy radiating from this gas giant is staggering. Our sensors are bombarded with data, and as we convert it, the sound envelops us. It's not a single note, but a complex, ever-shifting orchestration of static, whistles, crackles, and low-frequency rumblings. It sounds like an ancient, slumbering god, stirring its dreams manifesting as electromagnetic storms that ripple through space. Now, let's descend deeper, through the outermost layers of this magnetospheric cacophony, and focus on specific, utterly terrifying elements of Jupiter's voice. One of the most dramatic and powerful sounds emanates from its titanic lightning storms. On Earth, a lightning strike is a momentary flash, a sharp crack of thunder. On Jupiter, it's a continuous, colossal event. These storms, which can be 10,000 times more powerful than any lightning strike on Earth, generate intense radio waves known as whistlers. When you hear Jupiter's whistlers, it's not the sharp, sudden crack you'd expect from lightning. Instead, it's a drawn-out, eerie howl, a descending whistle that sweeps through the soundscape, often layered over the general roar. Each whistler is the electromagnetic signature of a lightning bolt so monumental, so enduring, that its radio energy propagates along Jupiter's magnetic field lines, creating this distinctive, haunting glissando. It's like hearing the ghosts of ancient storms, echoes of unimaginable power, rippling through the planet's vast atmosphere. The sheer energy involved is enough to make you instinctively recoil, a primal response to something so vastly beyond our experience. These aren't just electrical discharges, they are the planet itself, exhaling raw, untamed power. But perhaps the most overwhelming, the most truly terrifying aspect of Jupiter's soundscape comes from its auroras. On Earth, our auroras, the northern and southern lights, are a beautiful, often serene dance of light in the polar skies, a gentle interaction between solar wind and our magnetosphere. On Jupiter, the auroras are a violent, furious, and deafening roar. Jupiter's auroras are the most powerful in the solar system, radiating an astonishing 100 million watts of radio power. This phenomenon, known as decametric radiation (DAM), is picked up by our instruments as a sustained guttural scream. It's not a melodic chorus. It's a continuous, overwhelming roar, like a cosmic engine at full throttle, or the ancient god of storms bellowing its dominance across the cosmos. Imagine standing at the mouth of an active volcano, but instead of lava and ash, it's pure, raw electromagnetic energy being spewed into space, translated into a sound that vibrates through your very bones. This is Jupiter's voice when it truly lets loose. The sounds generated by these auroras are complex and dynamic. You'll hear sudden bursts, rising and falling tones that seem to signify a titanic struggle between the planet's magnetic field and the incoming solar wind. It's a symphony of chaos, a visceral reminder that some forces in the universe are simply too grand, too powerful, too alien for human comfort. The terrifying promise of our journey finds its full, profound realization here. This isn't fear of a monster under the bed. It's the humbling, awe-inspiring dread of confronting true, unbridled cosmic power. It's the realization of how small, how fragile, and how utterly insignificant we are in the face of such elemental might. What makes these sounds even more scientifically invaluable and deeply fascinating is how our human ears are uniquely suited to interpret them. The human ear, with its astonishing dynamic range, capable of discerning 1,000,000,000 to 1 in sound power, can detect subtle patterns, shifts in frequency, and hidden rhythms that might be entirely overlooked in a visual data graph. When Dr. Gurnett and his team first converted this data into sound, they weren't just creating a public spectacle. They were unlocking new scientific insights. The ear became a tool, an instrument for discovery, revealing the nuanced ballet of plasma waves and magnetic fields in a way the eye simply couldn't. It's a testament to the incredible power of cross-sensory data analysis. As we continue to orbit Jupiter, listening to its ceaseless roar, you might find yourself grappling with a sense of profound wonder, mixed with an undeniable unease. This isn't the gentle, almost predictable song of Earth's magnetosphere. This is the untamed heart of a gas giant, a planet that holds 318 times the mass of Earth, a world of unimaginable pressures, temperatures, and energies. Its voice is a direct reflection of its immense scale and power, a constant reminder of the raw, indifferent beauty of the cosmos. The sounds of Jupiter are a visceral payoff, a moment where the abstract idea of planetary power becomes a tangible, frightening, and awe-inspiring auditory experience. You don't just know Jupiter is powerful, you feel it, radiating through the simulated hull of our vessel. You hear the deep-seated rumble of its internal engine, the crackle of its monstrous storms, and the overwhelming scream of its polar lights. It's a sound that imprints itself on your memory, a testament to the fact that the universe isn't silent. It's just speaking a language we've only just begun to translate. Our journey to Jupiter, this rendezvous with the giant's roar, marks a dramatic centerpiece in our expedition. We've moved beyond the familiar, beyond the comforting, and into the realm of the truly alien. We've heard the voice of a cosmic leviathan, an ancient god screaming its existence into the void, a sound that is both a scientific revelation and a profound existential encounter. But the solar system still holds more secrets, more astonishing voices. What other incredible, perhaps even more haunting sounds await us as we venture further into the vast, echoing chambers of space? What will the next Titan reveal? Our journey has taken us deep into the heart of the solar system's grand symphony, and you've felt the visceral, raw power of Jupiter's untamed voice. The sheer force of that roaring beast, translated from the invisible dance of its plasma waves, still echoes in the very core of our being. It was a sound that didn't just rattle the sensors, but shook the soul, a primal scream of cosmic energy that redefined our understanding of what terrifying could truly mean in the vast expanse beyond Earth. But the universe, my friend, is a master of contrast. And as we leave the chaotic fury of Jupiter behind, we approach a world whose voice promises an entirely different kind of cosmic revelation. Look out now, beyond the fading storm clouds of the gas giant, and witness the serene majesty of Saturn. From our vantage point, its iconic rings shimmer like an impossible halo, a masterpiece of cosmic engineering suspended in the cold vacuum. It's a vision that has captivated humanity for millennia, a symbol of ethereal beauty and quiet grandeur. Where Jupiter was a thunderous proclamation, Saturn seems to whisper secrets, to hold an ancient melancholic wisdom within its icy bands. If Jupiter was the roaring beast, a leviathan of untamed power, then Saturn, we are about to discover, is something else entirely. A ghostly choir, an alien aria drifting across the light years, profoundly beautiful and deeply unsettlingly lonely. Prepare yourself, for the sounds of Saturn are not designed to overwhelm with brute force, but to envelop you in an otherworldly embrace. They are a haunting echo, a structured melody that speaks of immense distances and cosmic solitude. The data we've gathered from the Cassini spacecraft, that tireless explorer, which danced among Saturn's rings for over a decade, tells a story not of violent storms, but of intricate electromagnetic patterns, of a planet humming a complex, almost melodic tune into the void. This isn't the chaotic bluster you felt from Jupiter. This is a more subtle, more insidious form of cosmic wonder, one that resonates not with fear, but with a profound sense of awe and a touch of existential melancholy. As our systems prepare to sonify the data captured by Cassini's plasma wave subsystem, remember what we've learned. These aren't literal sound waves traveling through the vacuum. That's impossible. Instead, we are translating the invisible, the electromagnetic dance of Saturn's magnetosphere, its interaction with the solar wind, and the powerful auroras that ripple across its poles, into frequencies our human ears can perceive. Think of it as tuning into an ancient radio station, broadcasting from a civilization long vanished, its signals traveling through space for eons before finally reaching our receivers, translated into a language we can understand. Let us listen now to the haunting aria of Saturn. Sound, play, SKR, Saturn kilometric radiation, audio. A chorus of whistles, chirps, and sustained eerie tones, more structured and melodic than Jupiter's chaotic roar. Do you hear it? That ethereal chorus? It's unlike anything we've encountered so far. Jupiter was a guttural scream, a primal roar that tore at the fabric of silence. Saturn, by contrast, sings. But its song is not a joyous one. It's a symphony of long, drawn-out whistles, a chorus of rising and falling tones, a ghostly melody that seems to emanate from the very fabric of its ring system and poles. This is Saturn kilometric radiation, SKR, and it's a signature of the powerful auroras that flare around its magnetic poles, much like Earth's own northern and southern lights, but on a scale that defies imagination. The Cassini mission, a marvel of human ingenuity, spent 13 years meticulously collecting this data. Scientists like Dr. Donald Gurnett and Dr. William Kurth have dedicated their careers to capturing and interpreting these alien voices. Their work allows us to peer beyond the visual splendor of the SKR you're hearing is generated by energetic electrons caught in Saturn's powerful magnetic field, accelerated and funneled towards the poles, where they collide with atmospheric gases, creating those stunning auroral displays. These interactions produce radio waves that, when sonified, create this mesmerizing, almost musical soundscape. It's a sound that evokes images of ancient, silent ruins, of a forgotten temple where the wind itself plays an organ of immense scale. There's a profound sense of structure here, and yet, despite its beauty, there's an undeniable chill that runs through you as you listen. It's not the immediate terror of Jupiter's storms, but a more subtle, deeply unsettling emotion. It's the profound loneliness of space made audible. It's the sound of a world singing to itself, a distant alien broadcast that has traveled through the cold vacuum for countless millennia, carrying with it the echoes of processes far beyond our comprehension. This is the aha moment that deepens our expedition from one of simple cosmic horror to one of profound cosmic wonder. We began this journey expecting only the terrifying, the chaotic, the violent. But Saturn's haunting aria reveals something far more nuanced. The cosmos has an incredible emotional range. It can be beautiful, structured, and evocative, not just chaotic or violent. It can sing songs of profound loneliness, of melancholic beauty, of an alien majesty that stirs something deep within our own human experience. This revelation makes us ponder our own attempts to communicate with the cosmos. Think of the Voyager Golden Record, launched aboard the very probes that first carried plasma wave instruments into the outer solar system. It's a time capsule of humanity, a collection of our sounds, our music, our greetings, designed to drift through interstellar space for billions of years, a message in a bottle cast into the cosmic ocean. We sent our sounds out, hoping some distant intelligence might one day listen to us. And here we are, listening back. The universe is speaking not in a language of words, but in the elemental language of physics, translated into sound. The sounds of Saturn are a powerful counterpoint to our golden record. While we project our human story outwards, full of hope and curiosity, the planets transmit their own stories inwards, tales of forces beyond our everyday experience, of alien beauty, and of profound, almost heartbreaking solitude. As we move further from the ringed jewel, carrying the memory of its haunting song, we carry with us a deeper understanding of the universe's complex nature. The cosmos is not just a collection of silent, indifferent rocks and gas. It is a vibrant, sonorous entity, a symphony played out on a scale that dwarfs our imagination, each world an instrument with its own unique voice, its own emotional resonance. We've heard the roar of the beast and the aria of the ghostly choir. What other incredible, breathtaking, and perhaps even more profound melodies await us in the boundless depths of the cosmic ocean as we venture towards the very edge of our solar system and beyond? What hidden harmonies, what ancient echoes will our instruments next unveil? And what if we told you that we've already sent a messenger to that very edge, a solitary traveler who has not only reached the threshold, but has whispered back to us the sound of its crossing? Imagine for a moment that you are not just a viewer, but a crew member on an unprecedented audio expedition. You've navigated through the chaotic, roaring storms of Jupiter, felt the ethereal, melancholic chorus of Saturn. Now, we are pushing further, leaving the familiar orbits behind, heading into the deep, dark unknown. Our destination, the very boundary of our solar system, a turbulent, invisible frontier that marks the end of home and the beginning of interstellar space. This is where our story takes its most profound and arguably most lonely turn. For over 45 years, a spacecraft named Voyager 1 has been on an epic one-way journey, a testament to human ingenuity and an enduring symbol of our insatiable curiosity. Launched in 1977, this metallic emissary, no bigger than a small car, has traveled farther than any human object in history, over 15 billion miles or 24 billion kilometers from Earth. Think about that distance. Try to wrap your mind around the sheer scale of the void it has traversed, the countless years it has endured. Voyager 1 is more than just a piece of hardware. It is our farthest ear, our most distant voice. And its journey has allowed us to do something truly astonishing, to hear the moment it left our solar system. To understand how, we must revisit the concept we've explored throughout our journey. Space is a vacuum, yes, but it is not silent in the way we usually perceive silence. It is teeming with invisible energies, radio waves, magnetic fields, and what scientists call plasma waves. These are not sound waves in the air, but vibrations in charged particles, like ripples on a cosmic pond. Our human ears can't naturally pick them up. But Voyager 1 carries a special instrument, its plasma wave subsystem, or PWS. This PWS acts like a super-sensitive microphone, designed not for sound, but for these electromagnetic vibrations. When the PWS detects these signals, it converts them into electrical impulses. And here's where the magic, the true scientific artistry, of data sonification comes in. NASA scientists, led by pioneers like Dr. Donald Gurnett and Dr. William Kurth, take these electrical impulses, raw data essentially, and translate them into frequencies and amplitudes that fall within the range of human hearing. It's like taking the complex patterns of light from a distant galaxy and turning them into musical notes, allowing us to perceive them with a different, equally powerful sense. It's not a literal sound, but a profound, accurate translation of alien vibrations into a form our ears can interpret. The human ear, you see, is an astonishingly sensitive instrument. It can detect subtle changes, patterns, and anomalies in sound that our eyes might miss in a graph or chart. For scientists, this isn't just a captivating trick. It's a genuine tool for discovery, an alternative lens through which to understand the universe. For years, scientists debated where our solar system truly ended. Was it a crisp line on a cosmic map? A gradual fading? Voyager 1, with its steadfast journey, provided the answer. In August 2012, its PWS instrument began detecting a dramatic increase in the density of the plasma around it. This wasn't just a minor shift. It was a profound, unmistakable change. Voyager 1 had crossed the heliopause. The heliopause. The word itself sounds like a gateway, a frontier. And it is. This is the turbulent boundary where the solar wind, the constant stream of charged particles flowing out from our sun, is no longer strong enough to push back the interstellar medium, the plasma and magnetic fields that permeate the space between stars. Imagine a ship sailing out from a powerful river and finally reaching the vast, unknown ocean beyond its mouth. The heliopause is that moment of crossing, the place where the sun's magnetic bubble, the heliosphere, finally gives way to the greater galaxy. What did Voyager 1 hear at this momentous crossing? It heard the turbulent vibrations of the dense plasma of interstellar space. When this data was sonified, it revealed a profound and eerie hum, a kind of deep, resonant drone, punctuated by shifts and rises in pitch as the spacecraft encountered different densities and pressures of this alien medium. It sounds like the gentle but insistent pressure of an immense, invisible ocean. It's a deep, resonant hum, not unlike the sustained note of a vast, ancient organ playing a single, unchanging chord. But within that hum, if you listen closely, you can detect subtle shifts, a kind of ethereal hiss that rises and falls, almost like the breath of something impossibly large. This isn't the chaotic roar of Jupiter, nor the haunting melody of Saturn. This is something else entirely. It is the sound of a frontier. It is the sound of leavings, Listen to it. This is the sound of our solar system's final breath, a cosmic sigh as our farthest emissary slipped past the last vestige of home and into the boundless expanse beyond. It's an auditory marker, a sonic signpost telling us, you are no longer in Kansas, you are in interstellar space. The implications are profound. For generations, the edge of our solar system was an abstract concept, a theoretical line on a diagram. But Voyager 1's journey and the incredible data it sent back transformed that abstraction into a tangible, audible place. We can hear the moment our farthest emissary left home, Stowaways. We can hear the boundary itself. It connects us directly to the incredible decades-long journey of the Voyager spacecraft. Think of the sheer audacity of this mission. We built a machine, launched it into the void, and for over 45 years, it has been sending us whispers from the cosmic dark, each one a testament to human curiosity and perseverance. It's still out there, its PWS instrument, continuing to detect the subtle vibrations of interstellar plasma, a solitary sentinel broadcasting across the immensity. And there's another layer to this story, a beautiful, poignant counterpoint to Voyager 1's listening. When Voyager 1 and its twin, Voyager 2, were launched, they carried something else, the golden record. This wasn't an instrument designed to listen to space, but to speak to it, etched with sounds and images selected to portray the diversity of life and culture on Earth. Greetings in 55 languages, animal sounds, music from Bach to Chuck Berry, the laughter of a baby, the rush of a train. The golden record was humanity's message in a bottle, cast into the cosmic ocean. As Voyager 1 crossed the heliopause, listening to the sounds of interstellar space, it was simultaneously carrying our sounds into that very same space, a silent, enduring testament to who we are, where we came from, and what we value. It's a deeply human act, this dual gesture of listening and speaking across the vastness. This brings us to a crucial realization. The cosmic horror we've sometimes felt, the terrifying scale, the alien sounds, is balanced by an incredible, humbling sense of wonder. The terrifying aspect isn't about jump scares. It's about the sheer, unbridled reality of the universe. It's the profound existential awe that washes over you when you truly grasp the scale of what we're hearing. The sound of the heliopause is not a scream or a roar or a melodic chorus. It is the deep, fundamental hum of the galaxy itself, felt at its very edge. It's a sound that evokes the quiet solitude of deep space, the vastness of the unknown, and the incredible triumph of a tiny spacecraft that has journeyed where no human has gone before. This ability to transform the imperceptible into the perceptible, to turn data into a sensory experience, reveals a hidden dimension of reality. It's like discovering that a painting you've admired for years also has a scent or a texture you never noticed. The universe, it turns out, is not just something to be seen. It is something to be heard. From the inner turmoil of gas giants to the melancholic ring systems, and now to the vast humming frontier of interstellar space, we've journeyed through a symphony of the unseen. Each sound has painted a picture more vivid than any visual, evoking a sense of wonder and, yes, a touch of that cosmic dread that only the truly alien can inspire. We are listening to the universe breathe, expand, and interact on scales so grand they almost defy comprehension. But our journey, dear crewmate, is not yet complete. We have heard the breath of our solar system as it meets the galaxy. We have heard the farewell. Yet, there are even deeper notes, even more ancient echoes waiting to be unveiled. If the edge of our home sounds like this, what might we hear from the very oldest, most massive, and most mysterious objects in the universe itself? What profound, almost primordial hums await us from the cosmic abyss, from the heart of gravity's ultimate dominion. You've felt it, haven't you? That subtle shift in perception, the way your understanding of the universe has expanded, not just visually, but acoustically. We started this journey believing space was silent, a vast, echoing void. But you, my fellow traveler, have heard the truth. You've listened as electromagnetic whispers became the roar of Jupiter, a primal, untamed force thundering across millions of miles. You've experienced the ethereal chorus of Saturn, a haunting, melancholic melody from a world draped in icy rings, its kilometric radiation painting a portrait of alien beauty. You've stood at the heliopause, hearing the cosmic surf break on the shores of our solar system, a solemn farewell from our home as we ventured into the true unknown, into the dense, buzzing plasma of interstellar space itself, where Voyager's instruments still hum with discovery. But the universe, in its boundless mystery, always has another layer, another secret to reveal. If our journey has taught us anything, it's that the most profound truths often emerge from the most unexpected places, at the most extreme edges of what we thought possible. And as we seek those deepest, most ancient echoes, our gaze must turn not just to the edges of our galactic neighborhood, but to the very heart of cosmological structures, to objects so immense, so powerful, they warp the very fabric of space and time around them. We're talking about black holes. For so long, the very mention of a black hole conjured images of ultimate silence, of an abyss from which nothing, not even light, could escape. It's a cosmic maw that devours all, leaving only an absence, a void. It is the ultimate paradox of the universe, isn't it? An object that defines both creation and destruction, a gravitational tyrant that dictates the fate of galaxies, yet is often imagined as profoundly mute. How could such a thing, the very embodiment of cosmic stillness, possess a voice? How could the ultimate absorber of all information, all energy, all matter, also be a source of constant, palpable vibration, a ceaseless primordial hum? This, my friend, is where our expedition takes its most mind-bending turn. We are about to listen to the ultimate bass note, a fundamental frequency of the cosmos itself, resonating across unimaginable distances and through eons of time. This is the sound of the supermassive black hole nestled in the Perseus galaxy cluster. It's not just a highlight. It's the profound, resonant finale to our entire auditory odyssey, the deepest note in the universe. Now, before we delve into the terrifying beauty of this cosmic hum, let's be absolutely clear about something critical, a distinction that makes this particular sound utterly unique and even more astonishing. Throughout our journey, you've learned about data sonification, the brilliant process of taking invisible electromagnetic waves, like radio or plasma waves, captured by instruments on probes like Voyager, Juno, and Cassini, and translating them into frequencies our human ears can perceive. That's how we heard Jupiter's thunder, the powerful decometric radiation generated by its massive auroras, and the delicate, often eerie breathing of interstellar plasma. As Voyager 1 journeys through the void, its plasma wave subsystem still detecting the vibrations of dense plasma in interstellar space. Those were conversions, powerful and revelatory, of data we couldn't otherwise experience, turning abstract numbers into a sensory understanding that allowed scientists like Dr. Donald Gurnett and Dr. William Kurth to make profound discoveries. But this is fundamentally different. This is a sound in the truest sense of the word, that has been traveling through space for billions of years. It's not an electromagnetic emission, converted to audio. It's the detection of actual physical pressure waves, genuine sound waves, ripples that have propagated through the incredibly vast, hot, gas that permeates the Perseus galaxy cluster. Imagine a cosmic ocean of gas, filling the immense space between galaxies and this supermassive black hole, like a monstrous, impossibly slow-motion tuning fork, creating ripples, actual vibrations, through that ocean. This is the critical distinction: actual physical sound, not a mere translation of other forms of energy into sound. It's acoustic energy, just at an impossibly low frequency. This astounding discovery, this monumental act of cosmic listening, was made possible by NASA's Chandra X-ray Observatory. For over 2 decades, Chandra has been an unparalleled eye in the X-ray sky, peering into the hottest, most energetic phenomena in the universe, phenomena invisible to optical telescopes. And in the heart of the Perseus cluster, it found something truly extraordinary. It detected these ripples, these immense pressure waves, emanating from the supermassive black hole at the cluster's core. It wasn't just abstract data. It was proof of a physical disturbance, a primordial thrum that has been shaping its galactic environment for longer than our planet has existed. Think about that for a moment. This isn't just a powerful metaphor. This is literal sound, albeit on a scale so grand, it defies our earthly comprehension, a scale that humbles our very concept of existence. When scientists like Dr. Kimberly Arcand, a leading visualization scientist for Chandra, first analyzed the X-ray data, they saw these patterns, these concentric circles of gas, like ripples in a pond after a stone has been dropped. And they realized, with a breathtaking flash of insight, that these weren't just random structures. These were sound waves. They were the echoes of colossal explosions from the black hole itself, its powerful jets pushing out into the surrounding gas, creating these cosmic sonic booms. This revelation, especially when NASA released a newly processed sonification of this hum in 2022 for public outreach, brought the concept of cosmic sounds to a massive global audience, making the abstract tangible in a way few other scientific discoveries have. It allowed us to truly hear the universe as a dynamic, living entity, a vibrating force. However, these sound waves are at a pitch so impossibly low that no human ear, no conventional instrument, could ever hope to detect them directly. We're talking about a fundamental frequency so deep, it's almost beyond the realm of physical sensation. A sound that resonates more with the immense gravity of the cosmos than with our fragile biology. The calculations showed that this hum is a B-flat, but not just any B-flat. This B-flat is approximately 57 octaves below middle C, 57 octaves. To put that into perspective, the lowest note on a standard piano is an A, about 3.5 octaves below middle C. The deepest pipe organs in cathedrals might reach an octave or two lower, producing a rumble that you feel more in your chest than hear with your ears, a vibration that resonates in your very bones. But 57 octaves? That means one complete oscillation, one single wave cycle of this cosmic sound takes an astonishing 10 million years to complete. 10 million years for a single thrum. Your brain struggles to grasp that, doesn't it? A sound that takes longer to complete a single cycle than the entire history of modern humanity, longer than many species have existed on Earth, longer than most geological eras. It's a sound that has been resonating for billions of years, a constant fundamental thrum, since perhaps the very early epochs of the universe itself. It is, quite literally, the sound of eternity, a persistent fundamental frequency that underpins the entire Perseus cluster, shaping its evolution over cosmic timescales. To make this ancient, impossible note audible, scientists had to perform a precise act of sonification. They took those X-ray ripples, those pressure waves, and scaled them up, shifting their frequency by those 57 octaves, compressing billions of years of vibration into mere moments of audible sound. They didn't invent a sound. They simply translated an existing one into a register we could finally perceive. This isn't anthropomorphizing. It's a genuine scientific tool for discovery, allowing our exceptionally sensitive ears, capable of discerning a dynamic range of about 1 trillion to 1 in sound power, to detect subtle patterns and changes in data that our eyes might miss in a graph. It's turning a cosmic rumble into something we can finally register, a profound scientific instrument for analyzing complex datasets. And when you hear it, when you finally listen to that deepest note, it's not a scream or a roar or a whistle. It's a profound, almost primal hum. It's a resonant, deep throb that feels less like a sound and more like a vibration in the very core of your being, a physical sensation rather than an auditory one. It's the cosmic bass line, the foundational rhythm of a universe moving and evolving on scales that humble us all, a steady beat that has orchestrated the cosmic dance for eons. It evokes a sense of cosmic dread, not from fear of attack, but from the sheer overwhelming scale and power it represents, a deep existential awe. Think of it as the ultimate instrument in the grand cosmic orchestra we've been exploring. Not a delicate flute, not a soaring violin, but the grandest, most ancient bass drum, resonating at the very lowest register, providing the fundamental pulse for everything else. It's a sound from the mouth of eternity, a persistent, unchanging presence that underlines the dynamism of galaxies swirling, stars burning, and planets forming. It's the sound of the universe's own heartbeat, a rhythm too vast for us to usually detect, yet always there, a cosmic hum from the very beginning of time. This is the ultimate paradox, isn't it? The black hole, often considered the most silent, most isolated, most utterly void object in the cosmos, is revealed to have a voice, not a voice of destruction, but a voice of constant fundamental presence. It's a voice that actively shapes its surroundings, influencing the vast clouds of gas and dust around it, creating the very conditions for star formation in some regions and preventing it in others. Its hum is not just a passive sound. It is an active force, a cosmic engine driving the dynamics of its entire galaxy cluster, a constant conversation between gravity and matter. This mind-bending truth delivers the final profound dose of cosmic awe, transforming an abstract concept into something viscerally real, making the most distant and powerful object in the universe tangible. And what does this sound tell us? It tells us that the universe is alive in ways we are only just beginning to comprehend. It tells us that even the most extreme environments, the most seemingly barren voids, are teeming with activity, with hidden processes that can be revealed if we only learn how to listen, if we only create the instruments sensitive enough to detect their subtle vibrations. It tells us that silence is often a construct of our limited perception, a boundary imposed by our biology and technology, and that the cosmos is, in fact, a grand, intricate, and endlessly unfolding symphony, a vibrant chorus of cosmic phenomena. We began this journey seeking the terrifying, and perhaps, in that deep, resonant hum, you find a different kind of dread. Not the fear of a monster, but the profound, humbling awe of scale, of time, of forces beyond our imagination. It's the dread of realizing how truly small we are, yet how utterly connected to this magnificent, sounding universe. It's the terror of the infinite, transformed into the wonder of the fundamental, making the most abstract concepts of astrophysics tangible and real. This isn't cheap sensationalism. It's the genuine awe that comes from scientific discovery, from pushing the boundaries of human perception itself, from the crackle of Earth's magnetosphere, our cosmic home, providing a familiar baseline for comparison to the furious roar of Jupiter's storms, the haunting melodies of Saturn's rings, and the solemn breath of interstellar space. We have traced an auditory map of our reality. We have listened to the voices of our solar system, heard the farewell from our sun as we ventured further, and now we have stood at the edge of the ultimate abyss, listening to its primordial song, a reminder that existence itself is a vibration, a frequency, a note in a cosmic composition that began billions of years ago and continues to resonate forever. This journey, this auditory expedition, has transformed our understanding, hasn't it? It has opened our ears to a universe that is not silent, but vibrant, complex, and full of hidden voices. It has shown us that science is not just about seeing, but about perceiving in every way possible, pushing the boundaries of what we thought was knowable. It reveals a universe far more intimate, far more alive than we ever dared to imagine. It proves that sound in its most fundamental form is not just a medium for communication, but a profound tool for discovery, allowing us to hear the patterns and processes that shape the cosmos, linking us directly to the fundamental physics of existence. But if the universe sings this deeply, if even the ultimate silence of a black hole carries a note that resonates through eternity, then what other impossible songs are waiting for us to discover? What new frequencies of wonder, what unheard melodies of existence lie just beyond the edge of our current perception, waiting for us to learn how to listen, to build the next generation of observatories and instruments that will unlock even more of the universe's secret symphony, allowing us to tune into the very echoes of the Big Bang itself. Thank you for joining us on this incredible expedition, for daring to listen to the celestial enigmas. If you've been moved by the voices of the cosmos, if you've felt that profound connection to the universe through sound, please consider subscribing to Celestial Enigmas. We have so many more wonders to explore together, so many more secrets of the universe to unveil. We have journeyed deep into the cosmic darkness, together, you and I. We have traversed unimaginable distances, felt the invisible currents of space, and listened to the profound, sometimes terrifying symphony that pulses through the universe. We've heard the raw, untamed voice of Jupiter, a tempest of radio waves born from colossal storms and magnetic fury, a sound that rattles the very foundations of what we perceive as silence. We've felt the ethereal, melancholic hum of Saturn's rings, a delicate, almost mournful song that speaks of immense beauty. We even dared to listen to the deepest note in existence, the resonant B-flat from the black hole in the Perseus cluster, a sound so ancient we learned to translate the universe's whispers and roars, its electromagnetic data, its plasma vibrations, into a language our ears. This journey has shown us that the cosmos isn't just a canvas of stars. It's an orchestra playing an eternal, magnificent composition. But what if, after all this listening, after absorbing the universe's immense narrative, we decided to speak back? What if, this is not a hypothetical question. In 1977, these were the Voyager Golden Records, artifacts of our civilization, time capsules of humanity, intended for any intelligent extraterrestrial life form that might one day intercept them. Imagine the scene. These twin probes, now billions of miles from home. Voyager 1, over 15 billion miles, or actually 4 billion kilometers, from Earth, still venturing into the interstellar medium. Its plasma wave subsystem still detecting the vibrations of dense plasma, still sending back data from a region no human. It's a testament to our enduring spirit, isn't it? To hear the universe's terrifying might, its indifferent beauty, and then to respond not with fear, but with a collection of sounds representing our fragile, vibrant existence. These records were not merely scientific data. They were an intentional, deeply human composition. They were curated by a team led by the visionary Carl Sagan, who understood that if we were to send a message, it had to be a comprehensive portrait of who we are, what we value, and what it means to be alive on the golden record contained. Let's listen to First, the greetings. 55 human languages, from ancient Sumerian to modern Mandarin. Each voice a distinct cultural vibration, a unique way of articulating the simple phrase, hello, from the inhabitants of planet Earth. Imagine these alien ears, if they have them, encountering such a diverse chorus, each intonation carrying the subtle inflections of a different history, a different way of perceiving the world. These aren't just sounds. They are echoes of countless civilizations, of stories told around campfires, of treaties signed, of love declared, all compressed into brief, resonant moments. Each greeting, a tiny sonic fingerprint of a culture, a civilization, a history spanning millennia. Then, the natural world. The raw, unedited sounds of our home. The gentle lapping of ocean waves against a shore. A rhythmic pulse that has cradled life for eons. The sudden, powerful crash of thunder. A primal roar that speaks of atmospheric energy and the dynamic forces shaping our planet. The whisper of wind through trees. A soft, almost meditative rustle that evokes forests and quiet moments. The chirping of crickets, the croaking of frogs, the buzzing of insects, the ubiquitous chorus of Earth's smaller inhabitants, a constant living hum that underlies so much of our natural world. The song of birds, a melody that has inspired poets and composers for centuries, a pure, unadorned expression of life. The howl of a dog, a sound both wild and domestic, speaking of instinct and companionship. And perhaps most poignant of all, the cry of a baby, a universal sound of new life, vulnerability, and boundless potential, a sound that transcends language and culture, connecting every parent across every civilization. These are not sonified data. These are the actual sounds of our world, recorded with intent, a deliberate sonic snapshot of life as we know it, meant to convey the vibrant, teeming biodiversity of our planet. And then, the sounds of human activity, the rhythmic clatter of a train, a testament to our ingenuity and our desire to connect, to travel, to build. The rhythmic strike of a blacksmith's hammer, a sound of creation, of shaping raw materials into tools, a primal act of human craftsmanship, the distinct whirring and grinding of a tractor, a sound of our agricultural prowess, our ability to cultivate the earth, to feed ourselves. The crackle and pop of a campfire, an ancient sound of community, warmth, and storytelling, a reminder of our earliest gatherings. The gentle kiss of a mother, a sound of tenderness and love, a universal gesture of affection that transcends any barrier. The laughter of children, perhaps the most infectious and joyful sound on the record, a pure, unadulterated expression of happiness and innocence, a sound that speaks volumes about our capacity for joy. These sounds, taken together, paint a picture of our civilization, not through grand monuments or complex equations, but through the simple, everyday acts that define our existence. And finally, the music. 27 carefully selected pieces representing a vast array of human musical traditions. From the intricate, mathematical beauty of Bach's Brandenburg Concerto No. 2, a testament to our intellectual and artistic heights, to the primal driving rhythm of Chuck Berry's Johnny B. Good, a vibrant expression of our popular culture and youthful energy. Tuan hong kutat kokshwa, tram tukwa katnen van, huabanjia, wang fong chiu sao tumlain quan hanluai, jen hong kao trian jai kem shoots, by bong trongban giao huang, so pach kua Beethoven, am nak nai la noluk sao saknat kua, Jungta jasapsipam thun. Jatruyan tahi iningia. Kam suwa kauchuyan vaujo. Now kolelamot ngonan gufo quat. Tung them jam tre niemrat. Ring kwa kanungua chungta. Jo la sudang hien tim hon. Susang tao. Kat kau hoa hop vada hien kwa chungta. Nung lua chunam nas. Nai kong chila susap sep kat nor nas. Chung lan hung biu hien ko jong kwa kam shoots. Tritueva tingtan konungwoi. Juok thiut ke je giao tiep tsuyon. Kwa nung kawang kach dronglong kwa. Kong gyan va thui gyan. As these sounds play, let them resonate against the backdrop of the cosmic voices we've just heard. The roaring, indifferent plasma waves of Jupiter, the melancholic hum of Saturn, the deep, eternal thrum of a black hole, and then our tiny, intentional message, a baby's cry, a bird's song, a violin's lament. The contrast is staggering, isn't it? The universe sings its grand, terrifying, and beautiful story without conscious intent, a symphony of raw physics and cosmic forces. And here we are, a fleeting spark of consciousness on a small planet, attempting to sing back, to offer our own fragile, yet incredibly rich and complex, counter-melody. The narrative shifts now, from a listening session to a dialogue, or at least the hopeful beginning of one. We have spent this time deciphering the universe's electromagnetic whispers, translating its radio waves and plasma vibrations into sounds our ears can comprehend, finding patterns, meaning, and awe in what was once pure, silent data. We imposed our human sensory frameworks onto the cosmos, making its alienness relatable, its vastness perceptible. We turned its information into something we could feel, something that could stir our emotions and expand our understanding. But what about our message, etched onto those golden records, now hurtling through the interstellar void, carried by probes that have traveled further than any human creation before? If an alien intelligence one day, billions of years from now, were to find one of these records, to decipher its instructions and begin to play its contents, what would they hear? What would they translate our sounds into? We translated the universe's radio waves into a language we could understand, sound. But what if their primary mode of perception isn't auditory? What if they perceive the world through variations in magnetic fields, through subtle shifts in gravitational ripples, or through complex patterns of light? Would our 55 greetings, each a unique pattern of air pressure waves, be translated into a kaleidoscope of shifting colors, or a sequence of intricate, resonating gravitational pulses? Would the laughter of children, that pure expression of human joy, appear to them as a sudden, effervescent burst of energy, a cascade of shimmering particles, or perhaps a complex, harmonious vibration in their own equivalent of a thought field? Would Bach's intricate counterpoint, a marvel of human mathematical and artistic genius, be perceived as a series of elegant, evolving geometric forms, a dance of light and shadow, or a profound, ordered fluctuation in the fabric of space-time itself? Would Chuck Berry's guitar riff, that raw, electrifying burst of human exuberance, register as a powerful rhythmic pulse in their electromagnetic spectrum, a concentrated surge of energy that speaks of vitality and motion? Would the cry of a baby, that universal sign of vulnerability and new life, translate into a delicate, emergent pattern in their sensory data, a subtle but profound signal of biological development and potential? The very notion of sound is a human construct tied to our specific biology and the physics of our atmosphere. For an alien intelligence, our sounds would simply be another form of data. Complex pressure waves, variations in energy, patterns of information. Just as we turned their plasma waves into our sounds, they might turn our sounds into their own unique forms of perception. They might translate our music into a breathtaking architectural blueprint, our languages into a swirling nebula of abstract concepts, our laughter into a sequence of rapidly expanding cosmic blooms. This is the profound question that the golden record poses. We looked outward, and we listened, interpreting the universe through our human lens. Then, we looked inward, at ourselves, and created a message, hoping it would be interpreted by their alien lens. The act of sending the golden record is not just a scientific endeavor. It is an act of profound empathy and imagination. It requires us to step outside ourselves, to consider how another intelligence might perceive our existence, our achievements, our very essence, as we float in this cosmos, filled with these immense, often terrifying, but always awe-inspiring voices, the roars of Jupiter, the whispers of Saturn, the ancient hum of black holes, our tiny intentional voice, carried by the Voyager probes, becomes a testament to something extraordinary. It speaks not just of our scientific prowess, but of our capacity for wonder, our yearning for connection, and our audacious hope that somewhere, someone, or something might be listening. The universe sings its grand eternal symphony, and we on our small blue planet have dared to add our own fragile yet resonant note. This cosmic dialogue, though perhaps one-sided for eons, transforms our understanding of our place within this vast cosmic orchestra. We are not merely passive observers. We are participants, composers, and hopeful communicators. And as we continue to listen and to send our messages out, the greatest enigma remains. What will their reply sound like? And how will we translate it? The quest for understanding, for connection, for meaning in the vastness continue. And perhaps that is the most beautiful song of all. Thank you for daring to listen, for daring to imagine, and for joining us on this extraordinary journey through the celestial enigmas. If you've felt the thrill of cosmic discovery, if you've been moved by the profound questions the universe asks of us, please consider subscribing to Celestial Enigmas. Together, we'll keep exploring the boundless wonders that await, listening for the next unheard melody, and contemplating humanity's place in the infinite symphony.